Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, welcome. It's my pleasure today to introduce Dr. David Woods from the Ohio University of Columbus, Ohio. Dave is a full professor there and a professor of cognitive and human factors, in fact. Dave's skill, I've known Dave since like 1989 or 88. I think we have shared pedigree because we're both perceptual cognitive psychologists and our advisors go way back. But Dave's expertise lies in the area of critical decision making, and usually under uncertainty and pressure and in life-threatening situations, although he's done work in all facets of cognitive engineering. I remember when I first met him at Johnson Space Center, he was working very much in the nuclear control industry as well. So done lots of fascinating work with lots of different kinds of methodologies, and now he's going to talk to us a little bit about what he's learned about design, which will be interesting to hear. So welcome, David.
Thank you. So quick, before I do the big zinger to bring in all the people sitting at their desk, we do lots of cool things. We're about $1.5 million operation at Ohio State. You're going to see, and the talk is going to hit in indirect ways several of the themes in the lab. How do we make systems more resilient? Everything's getting brittle, right? To be more efficient, more lean. This is an overarching theme, especially in the safety area, but all aspects of complex systems. What's rigor in information analysis synthesis? This is the data overload problem. How do we find relevant data? How do we not make mistakes, which are often forms of premature narrowing or shallow or low rigor analysis? We're doing a lot of stuff with sensors and how do you integrate feeds from multiple sensors, be they a robot in a search and rescue kind of situation or surveillance networks, and make sense of them, drawing on our perception and attention background. You'll hear a little bit about how we're trying to help synchronize activities in crisis management-like situations. This is relevant to lots of areas, healthcare as well. And in particular, we've, like you, have been worried, like a lot of these organizations dealing with new human interactive technologies, how do we innovate? The world is changing rapidly, and we're constantly surprised by what the actual effects of new technology are. So let's start the talk. Users are in revolt against their systems. All right, John Graham, Colonel Doctor, has been traveling back and forth to the Middle East, and this was his summary line of what's going on as we're deploying lots and lots of new technologies into soldiers' hands. Users are in revolt against their system. Well, that's old news to us, right? I mean, we know, right? Users protest that people introduce clumsy technology. It thwarts the purposes of people. It creates workload bottlenecks, knowledge bottlenecks, attentional bottlenecks, so people work around them, right? How long have we noticed patterns like that? How many generations of theses have we gone through to show our chops that we can go out and find these bottlenecks and fix them? But that's not why John said this, right? When he said users are in revolt, he meant a deeper thing, that they're in revolt against the design process. They're in revolt against outsiders thinking that they can anticipate and out-design the difficulties and surprises and pressures of their world. They're in revolt because they feel with modern technology they actually have some design power. And they are going to go and create systems or modify systems to make them work for them in their critical situations. And that's really the themes I want to talk about. John's another way we've summarized John's point is we call the law of stretch systems. And the way I like to present this is from a previous, this result goes way back. You could say Winograd said it in 86. You can say Jack Carroll said it in 88, right? Task artifact cycle, things like that. What are we talking about here? Well, it was summarized really nicely in the late 90s on a major deployment of new technologies into a complex world. And the summary, the after-action report said, all this equipment deployed was supposedly designed to ease the burden on the operator, simplify tasks, and reduce fatigue. Instead, these advances were used to demand more. Almost without exception, Right? Operators were operation of the system required almost exceptional human expertise, commitment, and endurance. There's a natural synergy, right, between human factors, technology, and tactics so that effective leaders will exploit advances to the limit, asking people to do more and do it more complexly. Right? The law of stretched systems. Right? The systems under pressure, leaders under pressure will exploit improvements, new capabilities. The end result will be operational roles under greater pressure. Oops, I forgot to delete that. So where are we? We're really pointing out that people are adaptive, goal-seeking, meaning-seeking, explanation-building, tension-focusing learning agents. And this is really a contrast to most framing in HCI. Right? People are limited. Oh, those poor people. They're so biased. They will fall apart under uncertainty. But we will come and save them. Somehow it's only those other people who are limited. It's not us who hang out in research centers and innovation labs and know how to do all these fancy digital things, right? Or user testing or whatever. It's not, or we're great algorithm people, or we're the latest sensor people, decentralized. Whatever the latest technology is, it's those other people, right, who are the problem. So we design artifacts as resources, and we want to, the paradigm, the stance we want to push is that our designs are stimulants, are triggers on adaptive cycles. And two general kinds of adaptive cycles happen, right? And the law of stretched systems reminds us that we usually have expansive adaptations. Right? If there's a capability that's meaningful, people will find it, like they're exploring a niche in an ecology. Yeah, we may see the early adopters. What are they? They're active agents exploring and discovering new niches in their information ecology, right? We've heard these analogies before from other leaders in the field, right? And they will take advantage of that capability, and in that process they transform the nature of activity, the goals they're seeking, right? What's exceptional, what's typical, what are standard roles, right? Transforming activity, coupling, etc. Now, what we usually see is that most systems introduce bottlenecks, attentional, workload, knowledge bottlenecks, right? And so what do we see users do? Various kinds of gap-filling adaptations, workarounds and things, in order to be responsible agents to work around these new complexities to achieve their goals. Right? So our theme is, and what we really want to push in our organization and other related organizations, is that we need to really move beyond that we're thinking about devices and objects and features. Right? It's not enough to think about, we're going to support engagement and experience and activities in the world. Right? But instead we have to recognize and develop the foundations and the techniques and the concepts and the designs that look at our innovations are releasing cycles of adaptive behavior. And how do we model those? How do we trigger those? How do we understand those processes? We're trying to amplify the adaptiveness and resilience of human systems. And we're not playing these games about overcoming human limits. So the question is, what are the concepts, measures, techniques that we can use, and develop? What do we need to do? So here's the quick summary. Design triggers adaptive cycles. There's two kinds of adaptive cycles. That means we have design opportunities at 3 levels. Right? So people could do expansive adaptations by taking advantage of a capability to grow expertise in a role. I'll give you a couple quick examples. To better synchronize activities over wider scopes and ranges, right? Hyperconnectivity. And 3, expanding systems' potential for future adaptive action, resilience. How do we make systems better able to, right, deal with surprise and change in the world and still accomplish goals, or even redefine what are the goals that are meaningful to accomplish? Now, I'll illustrate that with a study from crisis management that we've done recently. I'll give a quick introduction to the new work that's emerging on modeling resilience of systems. I will try to spend more of the time focusing on, if you take this adaptive stance, what does it tell us about how to model technology change, and talk a little bit about our linked expansion constriction model, and we'll demonstrate that with a new study we just finished on the electronic intensive care unit and how that's been introduced to supplement actual intensive care units. So that's the plan. So what we're saying is if we take an adaptive stance, it means technology is going to trigger an adaptive cycle. You can think of it as 3 cross-link levels. Right? Growing expertise in a role, which partly is related to how a role participates in joint activities with other groups. Right? And so we have our distributed work perspective, synchronizing activities. But synchronizing activities is related to the ability to expand adaptive capacity, right, as an emergent property, resilience of a system. What makes for resilience in a system? Well, better synchronization. For example, cross-checks. We've done a lot of studies about how to make cross-checks work better in healthcare. If you don't have good cross-checks, what do you have? Right? You have coordination surprises. You have a system that is much more brittle. And likewise with expertise in a role. Now, the backdrop for this is a very old concept in human systems. And I think going back and looking through old writings, things even older than I am, right, 40 years ago instead of 30 years ago, we have not taken seriously a notion that has been around since the origin of human systems, research in human factors, which is the concept of fitness. Now, if you take an ecological perspective, you have to wrestle with what's fitness. Right? You can't, if you take an adaptive or co-adaptive system stance, you have to define fitness. You have to have an operational measure or approach to fitness. In fact, once people can define an adaptive system as something that's struggling to maximize fitness. It never achieves it in a long-term sense, because in achieving a certain level of fitness, what happens? The world adapts. In human systems, effective leaders will take advantage of your success. So at healthcare safety issues, patient safety discussions, we don't go back and say, oh, you're terrible in healthcare. If you just copied aviation, you'd be much safer. We come back and say, no, because you're successful, right, you actually create new problems. So because you're so successful in making certain healthcare procedures work better than they've ever have, right, what have you done? You've created a system where if you have a certain disease that fits one of their silos, you get the best care ever. But if you don't fit the silo, or if you have a chronic condition that crosses silos, this healthcare system is highly fragmented. So that second level becomes the critical one. We're really expert in a role. We're really poor at synchronizing or maintaining continuity across roles in healthcare. So fitness. So I just want to run through really quickly, because it ends up being a foundational idea that we have to take. We all do it. We all talk about it indirectly. We've got to take it seriously. We've got to better model it, better understand how to measure it. What's fitness? The search and struggle for fitness. It's another way to think about design, shifting away from usability testing and saying, what I'm doing is a kind of fitness management. How do I explore? How do I change definitions of what's fit? So what's fitness? The simplest notion, if you go back, of fitness is that there are various kinds of demanding events and changing situations in the world. All right, as those events occur, people develop behavioral responses, all right, to respond to these situations. Pick any field, right? We're learning agents as we confront various situations. We have experience. What do? We learn. We take responses. We get feedback. We learn. So we can in effect plot these sort of different proto-dimensions and then say, oh, wait a minute, the match between those is a kind of definition of fit. How do those relate to each other? Notice fitness is a relational variable. As you learn more in a local way, what happens, right? You get the set of behavioral responses that become more fit relative to the experience dimensions of the situations. As long as you're experiencing them, getting good feedback, right, you will learn no matter what. You're a learning system. You will learn something. We can turn it off, but only under very extreme conditions. Right? We are explanation building learning systems. What happens though? What we've learned about the world, given what we've experienced, is challenged. Right? The world's complicated, extra things happen. Right? Things go beyond the normal boundaries. Surprise occurs. Now that's a fundamental factor, right? Lucy Sushman pointed out to us with respect to the limits of procedures. There are always going to be, for practical and theoretical reasons, situations that challenge the boundaries of procedure systems. We make the procedures more complicated. We create new situations in which following those procedures will break down because of the variability and potential for surprise in the real world. So the potential for surprise means any algorithmic system has limits. Actually, we were warned about this by Norbert Wiener back in the late 50s, early 60s. Right? He warned us in a variety of stories in the human use of human beings, even though he's one of the fathers of modern computer systems, right, about being aware of the dangers of literal-minded algorithms, literal-minded agents. Why? Because there will be surprises that occur. The agent will continue to act as if these are the classes of events that occur when it's really in a different situation. So as we confront these kinds of complicating factors, these mismatches and breakdowns occur, we start to develop coping strategies, we develop extra adaptations. In some sense, this is already a definition of resilience. A resilient system is one that can respond effectively, not in terms of building this base level of fitness, but rather respond when complicating factors or surprises challenge the normal ways they behave to handle the normal range and variations of situations they experience. How well do they invoke extra adaptations to take care of these surprises and complicating factors? Learning something new about the system. So what I end up with is, playing with our Hal Usher image here, is this mantra. In design, we either hobble or support people's natural ability to grow expertise, synchronize activity, or adapt resiliently. Right? We stimulate their adaptive capability, or we undermine their adaptive capability. There is no neutral. There's no neutral. Right? That's an odd thing. You're either getting in their way, and they're going to work around you, or you're giving them resources that will participate, that they can seize upon in them adapting relative to their goals and pressures and the systems they exist in. And that's a really different stance. So a couple quick examples. So you know there's real specifics in our field about all this. Expertise in a role, well, we can run through things like Paul Feltovich and Rand Spiro's cognitive flexibility theory. How do we escape oversimplifications, the reductive tendency in their work? How do we recognize boundaries? How do we avoid premature narrowing information analysis? How do we broaden search? How do we revise assessments? How do we reconceptualize or reframe? If you look at sense-making work from Carl Weick and Gary Klein, right? In all of these, right, expertise in a role is more than just being expert at one piece of things, having autonomous action on one skill, one piece of things, but connecting those together and being able to revise and switch. Synchronizing joint activities. A lot of interesting things going on. How do we integrate diverse perspectives? We talked about that quickly today and last night. Anticipated reciprocity. A professor, I don't know if you ever took a course from her, she was there when you were there, Eleanor Ostrom at IU, right? Not in psychology department. Has some fabulous work on reciprocity as a model of trust. And it's redundant to put anticipated in there, but I want to emphasize that. Reciprocity is anticipated, right? I will do something in my role that may risk or consume resources, risk outcomes in my role, but I'll do it because it helps you in your role overcome difficulties or seize opportunities, and together we will better achieve overarching goals in our system. And if you analyze things like Tragedy of the Commons, you'll find that anticipated reciprocity is a fundamental requirement for effective joint activity where we don't fragment and spin off into you doing your role well, me doing my role well, and the total system going to hell in a handbasket, despite that. This turns out to be very important in accountability models in patient safety, for example, in healthcare areas. Directing it and redirecting attention, judging interruptibility. A lot of these are classic phenomena. You can put different labels on them in CSCW kinds of work, collaborative joint activity. And our favorite one is enhancing cross-check. So that's what we spend a lot of time trying to study and enhance. How do you make more effective cross-checks to enhance this collaboration and synchronization? Healthcare, crisis management, and layered sensing are huge opportunities for us right now. So let's do a study. We've been using crisis management as a natural laboratory. It's our standard method. We go out and work with real people who have to do are responsible for carrying out significant risky tasks. It's neat because people will spend money when really bad things can happen. But we do it in part because it's a great laboratory for getting data, because these people really have to work at what they do because they know bad things will happen, maybe to themselves or to people close by if they don't make good decisions. One of the studies we just finished is a critical incident analysis of a major metropolitan fire department somewhere between Boston and Philadelphia on the East Coast. I wonder where that could be. And they'd made available some of their firefighter injuries and deaths cases. When we break out some that just happened because this is just dangerous stuff, and you start looking at the coordination surprises, we start to see how there's a variety of things they do to prepare for these episodes that create cohesion. But the inherent difficulties they tend to approach, remember, fires are relatively spatially contained, at least initially. So they approach and initiate their activities effectively, but the inherent difficulties of communicating, what we find is they start to work at cross purposes. And working at cross purposes is one of the classic signatures of a synchronization breakdown. So opposing lines, so one group is hose line is driving the fire towards the other group. Venting can do it. So if you vent inappropriately, you can actually increase the intensity of the fire towards, remember the movie Backdraft? Towards the other group. And in a huge percentage of the cases, these kinds of working across purposes play out. Someone gets injured, they reconfigure, they have a crisis, a new crisis within the crisis, which is to deal with or rescue an injured responder, and eventually they have some kind of resolution to that situation. So some very interesting kinds of things you can look at about the synchronization. But I want to tell you about a different study. It also illustrates the kind of way we use natural labs. So in this case, it's the new capability is you can put sensors out in the world. And you can understand remotely. Before you couldn't, if you were a commander, for example, in a crisis, disaster, chemical plant fire, say, you were remote. You weren't on the scene. There were people on the scene. You were trying to share information. You had different roles. Well, with new sensor technologies, you can be on the scene even though you're in the command center. One of the ways is a UAV flying around. You get the video feedback in the incident command post. People love it. And if you've been in any of these incident command posts or a military command post with these UAVs, everyone loves the UAV feed. So we have this new capability. People adapt to exploit it. In fact, they are so captured with it, they overutilize it, over-rely on it. And everybody who sees this goes, I wonder if this is creating a danger. And it's changing the roles, creating a success, and creating new vulnerabilities, new forms of breakdown. So we said, let's study it. How do we study it? Well, right? We have a bunch of reasons we would worry about over-relying on one data channel. Right? Premature closure, framing, your hypothesis generation, and is framed by the image. You may be unable to revise effectively if the data comes from a different information channel. So what do? Well, we create a staged world. Right? We want to have a realistic rendering, but we want to be able to repeat the problem and run it for a variety of real people. So we were able to track down 8 different real incident commanders in the Midwest who do this with a reasonable amount of experience. We set up a command post setting. That's pretty easy to do because what are they? Rooms with lots of paper and a couple computer screens. The only thing unrealistic is we didn't put as much noise in the background as would really be going on as people came in and out and talked in the background. What did we do? Well, we flew around and took pictures of a chemical area, and we created digitally a fire. And so we simulated a UAV feed. Not quite as realistic. So then you design an event. How do we do that? Well, in this case, we took a real accident that had happened a few years ago in England, and we modified it a little bit, and we did a garden path problem. And so in a garden path problem, the imaging channel suggests an initial plausible diagnosis. Later, subsequent data comes in that's contrary to the current diagnosis, and it comes in outside the imaging, the UAV video feed. All right, give them a second opportunity to understand what's going on. All right, so the question becomes, do they revise? And so what do we end up doing is 7 of the 8 commanders went down the garden path. right? They were stuck in the initial plausible diagnosis. They over-relied on the video channel. And when you look at the details of what they did, again, only one avoided the trap, but the ones who were caught were using fewer data sources, had limited cross-checking between the data sources, all right, and had a variety of anomalies in the data that they did see relative to their hypothesis that they didn't recognize and follow up, that their hypothesis really didn't account for everything they had seen either. Right, so they were doing a poor job of understanding what was going on in a dynamic, uncertain situation. Now, let's pause for a moment. In some ways, you can say that's a classic situation we're in. New technology has an upside and a downside, cognitively and collaboratively. Here we're identifying that upside and that downside. You don't want to throw out the baby with the bathwater and say, don't use this stuff. They will use it. It creates a new challenge for us. Let's design better visualizations that help people balance diverse heterogeneous information sources. Some will be more compelling under some circumstances or most of the time. Right? Some may be, some abstract data sources may be less compelling. Sometimes they may tend to believe people on the ground. Maybe they don't believe people on the ground. Maybe they can't translate what they're getting on the ground because it's in a verbal form versus a sensor, a data sensor form. It's reading certain readings about contaminants versus a concrete visual, right? Very diverse formats. How do we integrate and balance those? Great research questions for us. Fabulous for the visualization community. Very important, very relevant. We're being reactive to an adaptive cycle. Now we're trying to influence the adaptive cycle. So in some sense, I'm coming back and saying, what do we have to do? We have to get ahead of these adaptive cycles. How do we look further ahead? How do we start to understand what's going to trigger what kind of adaptive cycle? What's going to dominate? Is the expansive adaptation going to dominate in the video feed example, the UAV example? Are the bottlenecks going to dominate? Right? In this example, we can predict pretty much what's going to happen, right? The new capabilities are highly attractive. The deficiencies only happen when you actually do this, right? And so you don't usually do this, so we don't notice you do it wrong, right? And when you do it wrong, there's always a simple excuse, right? It's human error. What do we need? More technology to overcome those erratic other people who aren't as smart as we are. Instead of recognizing, right, that these are fundamental challenges for any human system because the system, however automated, however many fancy algorithms, however many fancy virtual technologies, in the end is about human purposes. Right? We're trying to have a safe world, an effective world, an energy efficient world, access to equity and access to healthcare, etc. So what we're really at is at the time to take advantage of all the advances in ecological and adaptive system modeling and start to bring it into understanding and designing human systems. That means we have to start thinking about that third level. How do we expand adaptive capacities? How are systems resilient and brittle? How do we see hidden dependencies in coupled systems? Fundamental in software reliability, software dependability issues. How do we track side effects in replanning? We adjust it. We have all this great new information. We can see that situations are evolving rapidly. We can take advantage of that instantaneous information, and let's change directions to take advantage of this or to cope with this new information. What happens? We miss side effects, other effects that are associated with the changes in plan and direction and activities. And so we end up with that as a typical kind of failure. Rigor and information analysis. We have access to so much data. We think we have enough data to make a reasonable decision on, for example, a space launch. Is a foam impact a safety of flight risk? Or is it just a throughput risk that we have to handle this on the turnaround for the next launch of the space shuttle? So we have low rigor, shallow analyses justifying, right, it's only a productivity issue. Why? Because they're under high productivity pressure. All right, and you have these rationalization, discounting processes going on. No one sees that it's in fact a low rigor analysis. In fact, if you looked at the real data, right, these are more energetic than they had any actual models to predict. They were striking parts of the vehicle that no one had, that weren't the usual parts that they were worried about structurally. So no one knew the structural limits of the leading edge device on the wing where it actually struck in Columbia. And so you end up with a situation where there's these key warning signs, right? You have a shallow, low, actually zero rigor analysis. You move ahead and all of a sudden, boom, you're surprised by an unlivable vehicle. Complexity costs of creeping featureism are a great example. Some people might say they're a great Seattle example. We put out systems and we keep adding things. How do we recognize when the complexity costs dominate the incremental fitness value, right? What do we need? A fitness space, right? Complexity costs are looking at an aggregate over the fitness, shifting our fitness definitions from very local, right, to more global things that require us to take a broader stance on what people are trying to accomplish in the world. And so we have to think about how systems are resilient and brittle and develop models like that. Now, adaptive capacity, right, that's been our theme all along today, is to say that we need, as partners, right, as different research organizations, to take this adaptive stance seriously and develop these new tools. And one of the interesting things about adaptive capacity is that it's about the future. Right? Measures of adaptive capacity are about your ability to respond to future surprises. But the only way we can assess that kind of adaptive capacity is to look at how the system responded to past opportunities or disrupting events. So we look at how you adapt in the past, right, in order to assess your potential for adapting meaningfully to future surprises, even though we don't know what the future surprise is going to look like. So adaptive capacity becomes a generic kind of thing, generic kind of system capability that we could measure based on what the system does now or in the recent past, but it's an important variable because it tells us how the system is likely to behave in the future, even though we can't predict the exact disrupting events. In fact, that is the definition of surprise, right? Which is, right, that future events will challenge in smaller or larger ways current planful activities, right? How likely are if you just behave according to plan, routine, typical contingencies that you've done in the past, how likely is that to work in the face of future events? So what's a great place where this plays out? Emergency medicine is a great place to think about this. And in emergency medicine, you can think about systems, and you can say, emergency medicine is designed to handle varying loads. Well, one of the interesting things is there's a report from 2 years ago from the Institute of Medicine saying that the emergency department is the brittle point in the national healthcare system. Why? Well, ask the head of the Emory ED. The Emory ED handled the Atlanta Olympic bombing. So Olympic year. And what was the casualties there? 2 dead? 12 wounded, I believe, something on that order. I haven't memorized the exact statistics. The Emory ED head is very proud of how they handled that mass casualty event. And he has stated publicly that if the Atlanta Olympic bombing happened today, his ED could not handle it, much less anything larger. Could not handle it. Erosion of expertise, more rigid environment, inability to shift rules and authority, lines of authority, depleted physical resources. Right? EDs are under-resourced relative to increasing demands, more cases, more diverse cases flowing through. Recent studies showed that EDs start to sacrifice normal quality of care indicators almost as soon as patients show up at the door. So normally you think of an ED, it would start sacrificing things as surge levels got high. Turns out you start seeing some things being dropped as soon as you get a couple difficult patients. Doesn't take much to challenge these things. So what do you see in an ED? You see a lot of adapting. As loads go up, you can learn a lot about, right, cognitive strategies and how they change, how they utilize physical resources in new ways, how they change patterns of teamwork, assignments, roles, communication strategies. All of these things adapting in order to keep the system intact. Right? What's a failure? Well, you have interesting things going on. If you're in charge of the ED and you're starting to run out of capacity, what are you doing? You're anticipating that ability. Can I handle the patients? Right? So a logical thing from your point of view, say, I'm getting too close to capacity. I might mishandle a patient. So we'll divert patients to other EDs, other hospitals. Patient dies on the way to the other one or waiting at the other ED, what happens? Scandal in the paper, right? Who's to blame? This hospital. What does your hospital director do? Gives you a new policy. You can't divert. All right? So is diversion a failure or is diversion an adaptive strategy? It's both. All right? Now you can't divert, so how do you handle patients? Well, now it's your mistake, not the hospital's mistake, if you can't handle all the patients you have to deal with. Surge capacity modeling EDs is one of the hot places where we're trying to understand. Again, a place that needs this and can now, as you innovate new technologies, how do they support the adaptive capacity, the ability to change and escalate these strategies as loads escalate to stay resilient? Right? On the other hand, it's a perfect natural laboratory for us to model and understand these processes. All right, and how do we develop technologies and designs to support it? All right, so this is the big theme. How do you manage systems resilience? How do you assess brittleness? How do you do this kind of stuff? We can draw on ecological and some math modeling kinds of large-scale complex systems. There's a variety of kinds of basic principles that we don't have time to go into today. How are we on time?
About 15 minutes.
Okay, let me skip that example. I already hit this. Let's skip up to the technology change issue. So if we're taking this adaptive stance, then what that tells us is we have to think more about models of technology change. So this is an old animation we did a long time ago. The black box of new technology hitting ongoing fields of practice, creating a variety of reverberations of change. Right? Let's go play that again. Right? An ongoing field of practice defined by artifacts, various kinds of agents and collaboration, given demanding strategies in the world. The black box hits it. Processes of transformation occur, new complexities. People adapt in various ways. Failure breaks through, usually gets blamed on human error. Right? But in fact, we see new capabilities, new forms of coupling when we take advantage of those, new forms of tempo, new complexities for people to take. How do we understand and anticipate the side effects of these changes? Well, the classic model of technology change is technology adoption, early, late adopters, the Rogers S-curve. Now, there are some other models that are starting to move beyond this, but this is the classic one. Now, this is an enormously weak model for understanding what's happening with computer-based and digital technologies. Jonathan isn't here. This is the part where I would talk all about him.
Say hi, though.
Yes.
He's on vacation.
In Ohio, of all places. And so one of the great examples that you can't explain with this is systems that fail. And you can't explain systems that fail due to workload bottlenecks. Right? So the classic phenomenon that we see over and over again where in your role, in my role as an administrator, I get all the benefits if you take on new workload associated with the introduction of this new technology. But you're already under workload pressure. Right? So you get no advantages, but you're supposed to do these things, so I, in my role, get advantages. And normally those things fail. And you can read this large in many of the medical information technology failures. So for 3 decades, they've been trying to put in computerized medical records. What often happens is exactly Gruden's law, right? The people who pay the workload penalty don't get benefits for their role. They're already under workload pressure or even workload saturated. So naturally, these systems don't go very far. They don't explain adaptive expansions, right, which is successes don't take the form of what designers anticipated, but users create new, exploit the capabilities to do new things that no one predicted. Law of stretched systems, CoAdaptive processes. So what did we do? So we started, let's take these adaptive things, even in a simple descriptive way. We've got to start moving forward, right? Start taking advantage of these other areas that have developed different ways to do multi-agent co-adaptive simulations and things. What's a simple way to think about a role in the world? Is a role is like a performance track, and the performance track is defined, at least when a role is well practiced, right? Relatively stable environment, stable background system for funneling people into the role. Think of it as a nice geometrically regular track, performance track. The performance track is defined by facets over 4 dimensions. We've got our workload dimension, right? Gruden's law, we've got to have a workload dimension. We have an expertise dimension, right? Technology change can introduce new capabilities for us to exploit in terms of new forms of expertise. We have an economic boundary, right? Efficiency, productivity, economic gain. We introduce these things. People want to get, right, see productivity or economic gains from it. And then we've been debating whether to call this a safety or a risk or an adaptability. Let's just say for right now, think of this as a risk kind of dimension in a variety of facets where we are anticipating that things can break down and go wrong badly, right? And we do a variety of hedges and adaptations so that we don't have major failures in some sense, okay? 4 classic kinds of things, all right? This role isn't an individual, it could be a whole group. An ICU could be modeled as a role, all right? An ICU doc could be modeled as a role. An emergency room could be modeled as a role, or an individual sub-team within that could be seen as a role, the cardiac group, right? And we have these dimensions, right? So what happens when you throw new technology? Well, you can have constrictions or expansions. So we have a simple way. Our track gets, right, bottlenecks thrown in. You can't go in a straight path. You've got to go around. Or we could break this path and say you've got to fill the gap. There's a hole in the path. You've got to reconnect the path in order to continue to do your job. Simple visual metaphor for the workarounds, right? Gap filling. But you have the possibility for expansions. Right? So think of expansions like niches. Now notice with an expansion it's different. With a constriction you run into something. If you just keep going you run into something. So you've got to go around. You've got to deviate from the usual things to make it work. In an expansion you can keep going in the old way, but a new niche has opened up. That's the way you would think of it in ecological systems terms. A new niche has opened up and people explore, right, who are thrown off the routine track start to discover, oh, wait a minute, here's something new I can take advantage of. What happens over time, right, is, right, we renormalize because we experience these as regularities in our environment. We take advantage of this. That defines new routines, new practices, right? We have standard ways to work around. We learn these. We develop these. We transmit these to other people come in. Boom, boom, boom. We're now into a regular performance shape again, a regular track again. And you see this very nicely as people develop new experimental procedures in healthcare. They start to move them out to other settings until it becomes a routine accepted and paid for by insurance kind of measure. All right, so let's look at this happen. And so the place we went to look is the electronic ICU. Electronic ICU. So what's the electronic ICU? It's a remote facility meant to support the physical ICU. What's physical ICU? That's where the actual patients are. So electronic ICU has access to nurses and doctors in a remote facility who are looking in, doing vital sign monitoring, other forms of looking and communication. For example, they can have video, remote cameras they can control to look at the patient, look at the equipment set up around the patient. They get telemetry on vital signs monitoring. They can help out the nurses. Why would you want to do this? Well, the ICUs are under a lot of pressure. And you can see that as economic pressure. You can see it as expertise pressure. Right? There's a shortage of experienced nurses, qualified people. In rural environments, there can be a shortage of specialized expertise for different conditions in the ICU. You can have a small hospital that has a general ICU, but may not have enough people to cover all of the different specialties issues that may arise for a particular patient. So you can expand the access to specialized expertise, a lot of different things. So what did we do? Well, we did the classic kind of stuff. What is it you start with? You go out and look. So we got access to an actually ICU and we hung out with them. Started to observe what they did. Based on that, we started to do a cognitive task analysis of what are the different ways the EICU is being designed and operated to support the physical ICU. What was really critical was they were logging their interventions. In other words, when did the EICU intervene to help the physical ICU? Or maybe the physical ICU didn't think of it as much help, but there was some interaction. And since we had these logs, we had the ability to take a longitudinal study. What were the kinds of interventions and how were they changing over time? Well, if we're going to look at adaptive systems, we've got to start adopting longitudinal methods. We can't just look once. We can't just say how do people react at one point in time in a learning curve, right? How are they going to start to recognize the value and adapt that into their situation? We started out with worried about, well, gee, these things are going to support anomaly recognition, especially, so monitoring help. The nurses like to call it extra eyes on the patient. Sense-making kinds of functions. For example, we saw issues where the people in the EICU could step back and take a big picture approach, right? Revise, wait a minute, patient wet or dry? Are we late or early? Are we overreacting to something and overdriving them into the wrong state, kind of thing? The people in the physical ICU, right, have a lot of physical tasks to carry out. They deal with the patient family, variety of attendings and residents coming in, a lot of interruptions and things. Interruptions, right? So all of a sudden you can start saying, the EICU is valuable because they're a more stable environment relative to monitoring. A lot of potential pluses. Specialized expertise, that was a key one we thought would be valuable. Well, we didn't. Best practice reminders, maybe that's sort of a sense-making kind of thing, but basically giving feedback to the physical ICU as to various interventions they need to be doing. In some ways, this is stepping back from the detailed flow and saying, oh, there's other tasks you haven't carried out yet that should be on your priority list. One we didn't realize would be there was mentored learning. The EICU nurses tended to be fairly experienced nurses, and in the kinds of ICUs that needed an EICU tended to have more junior. They were licensed, but they were more junior in experience. They were very junior in experience levels. Yeah.
What was the mechanism for communicating between the EICU and ICU?
They had telephone linkages. They had video. Well, there was two-way communication, they ended up calling. All right, so they had dedicated lines to call and talk to them about what was going on. That's one of the predicted trajectories is the EICU can now become a source of interruption and inappropriate interruptions. If they don't have effective common ground, how do you get effective common ground? Is the video interplay critical? Right? Not just to see what's going on with the patient, but also to see what's going on in the physical ICU and the nursing loads to know when to interrupt and interact appropriately given what is going on. So you can think of it as being an ICU under a variety of pressures, variety of constrictions, economic constrictions, expertise constrictions, and workload constrictions. What do you see? You see people taking advantage of, we can avoid risk, we can adapt in a variety of ways by taking advantage of these remote monitoring capabilities. You see a transition, and now we've moved we started this study 2.5 years ago, and the number of EICUs in the country have doubled or 2.5 times from when we started the study. So we weren't at the very beginning, but we were early in the migration, and it's been taking off. So this is a success story. People are adapting to take advantage of this. Different ones are configured differently because of their particular geographic area concerns, and we're starting to see it normalize into a new pattern of activities. What are we interested in is predicting what's going to happen next. Well, we saw one of these things happen because it was a longitudinal observation. There was one thing on that list I didn't mention. Billing. So what happened? All right, hospital administrations under various, these are notional, don't take these as the literal point from the data, but notional, they're under various pressures that create constrictions, and from the hospital's point of view, finances, right, are a big one. What are they looking for? Looking for ways to be healthier, and here's this EICU, which is in their environment is a resource that they can seize upon and use to adapt hospital procedures. So what do? They start introducing workload into the EICU, saying, EICU, your job is to monitor the physical ICU to make sure they enter things in a way that maximizes our ability to bill. Not improve patient care. Not access specialized expertise. What do you see? You see this thing where a success can start evolving into a maybe not quite a success, or the grounds for an accident that we could then come in and investigate and go, oh, look at how this was a system failure. Look at how the origins of this accident begun years before in organizational decisions, how this is an organizational accident, not human error. I don't want to be there. I've been there enough. I want to prevent those things from happening by being proactive. So we saw this trend happening. So part of our analysis is trying to project adaptive trajectories. And how do we do that? well, without going into all the things, I just wanted to illustrate on these how we related a variety of sustainability conditions. So that's one of our new themes here is you have a new capability that's seen as a niche. Effective leaders start to recognize the niche and exploit the niche and expand the niche. As they do that, they have a variety of effects, right? It's a linked expansion constriction. Expanding on one dimension and the facets can create constrictions on other facets, other dimensions for that or other roles. So the issue is let's identify sustainability conditions and say if those aren't met, what are we going to see? We're going to see this erosion. Instead of benefits on the expertise and quality dimensions or risk dimensions, we're going to start to see benefits and financial ones erode those expertise gains, and we'll start to see the risk of failure go up. So we can start to see some of these common patterns that our studies reveal. So the extra eyes, right, better monitoring is great, but that assumes the EICU isn't task loaded with other additional administrative or other kinds of tasks. If you've got a bunch of people sitting around, not much is happening, how are you going to load them more? How are you going to load them more? Well, if you're monitoring 3 physical ICUs from one EICU, why don't do 5? Wait a minute, we can get more billing. Well, let's do 7. Whoops, wait, right? All of a sudden we see economic interests of the entity running the EICU increasing the workload, either direct monitoring or indirect tasks other additional tasks gets transferred to the EICU. All of a sudden that monitoring expertise goes away. Best practice reminders. Those are interruptions from the physical EICU's point of view. If you don't have mechanisms for effective common ground, what are you going to do? You're going to have bad collaboration. We've studied these things over and over again, and in healthcare in particular, interruptions are a very simple correlate of mistakes. High interruption, more mistakes in these routine activities. Administrative billing task complexity creep. The sense making, your ability to step back and take a big picture approach. That wasn't one of the high frequency gains, but it was potentially a critical gain relative to outcome if your patient, if your relative or you are in the ICU, right? You care about that a lot. Again, as tasking goes up, how are they going to be able to step back and take a big picture approach, make these high level judgments that may be difficult for the nurse on the physical scene because they have so many activities and interruptions there that are going on. Specialist expertise. Well, one of the interesting things about the EICU that nobody noticed is part of the reason the EICU is working right now is because there's a pool of available expertise. So older, experienced nurses who no longer want to deal with the physical rigors of being on shift in the ICU. So you've got experienced nurses, older nurses, they want to work in a different style, they can have a better lifestyle, or they can work shorter shifts part-time in the EICU that they wouldn't work in the physical ICU. Now when that experience base gets consumed, will some of these benefits still hold? Mentored learning, you can't have mentored learning if the people in the EICU aren't much more experienced than the people in the physical ICU. You're not going to have the same access to specialized expertise. This isn't simply to physician expertise, it can be also to experienced nursing expertise. So a sustainability condition is that there's an experience pool available to draw on. So what we're starting to do is starting to say, hey, wait a minute. As a field, we know a lot about these adaptive trajectories. We use them all the time in the way we design studies, in the way we make recommendations and critique interfaces and run usability studies and innovate new designs. But we don't organize any of our knowledge around adaptive trajectories. We don't organize our knowledge and techniques around assisting and predicting and steering these adaptive trajectories. But maybe we should.
So the idea of the experience pool and perhaps all of those adaptations that you talked about, I had sort of been thinking of them as sort of unidirectional, that the experience pool only benefits the EICU people with more experience can now benefit the ICU people. The flip of that, and this is maybe true for lots of these different sorts of adaptations, is maybe the people in the original system, in the ICU in this case, can now provide additional learning for someone that might be at this remote location. I don't want that person in my, that newbie in my ICU but yeah, sure, they can over their shoulder in the EICU and be out of the way and get this sort of high-level thing, but still get some mentorship.
What did he do? What did he do? He just did an expansive adaptation. He said, oh, wait a minute, if I want to train nurses, all right, what do? I start bringing them through the EICU as a mechanism to get them up to speed before they have to deal with everything, as a way to get concentrated and safe learning, because in the medical world we don't want people learning on real patients. That's one of the trends out there, right? So we're doing more crisis simulation, other forms of medical simulation are starting to penetrate and spread. It's still relatively early, even though they're available in most metropolitan areas, at least 1 or 2 centers. But right, that becomes, oh, wait a minute, another trend, another set of constrictions. Here's a resource I can take advantage of. Right? And so that's what we want to do, is we're saying, how do we start mapping these potential trajectories? Now, one of the other ideas I didn't put up on the slide is, how do you monitor? We may not be able to absolutely predict ahead, but at least we can detect early emergence of these trends. Right? And so your idea says, I don't know for sure they're going to adapt in training, and I'm not going to make a Las Vegas bet that the adaptation is going to be new training mechanisms. On the other hand, that's one of the potential trajectories. Notice we can come up with this by applying our general knowledge of human systems and new technology and HCI to these things. We don't have to know a lot about this to know, hey, that's one of the potential trajectories. Then the question is, set up monitoring conditions. Right? So now we'd say innovation monitoring conditions. How would we notice if that was turning out to be adaptively valuable to the user community, these human systems? And then all of a sudden you go, oh, wait a minute, it turns out it's training. We can help you take advantage of that and do that in a good way rather than a poor way. Remember the cross benefits and weaknesses in our UAV example for incident command. The technology capability created new vulnerabilities. At the same time, it provided new benefits for the incident commander. And so we don't want to get in these simple, well, you just have to take the bad with the good, over-automation, human error, back and forth, games that don't get us anywhere in terms of overall system design and system capability. So we need to start being able to use our knowledge. It's already halfway there, at least, to be able to talk about emergent patterns that are, across local adaptations. Right? That means we have to start integrating these multiple perspectives and different levels. Right? So we had the hospital administration, ICU, physician, right? Nurse training, all these different perspectives interacting. How do we anticipate adaptive traps when they're going to get stuck? A classic example we're all dealing with right now is corn ethanol. Great example of an adaptive trap. And it's also an example of an adaptive fluorescence. Can we recognize, all right, linked sets of adaptive expansions where one adaptation, there's an expanded niche, somebody adapts to take advantage of it, that creates another expansion which somebody takes advantage of, which creates another expansion, that's an adaptive fluorescence. The emergence of corn ethanol was an adaptive fluorescence. It turned out to be an adaptive trap when you took a larger perspective that we're stuck in right now. Right? That was the news driving over, was cellulose-based ethanol. That'll get us out of the adaptive trap. Notice the key theorem behind an adaptive stance. In adaptive cycles, all right, yesterday's solution produced today's surprises that become tomorrow's challenges. Right? It's not about right or wrong, good or bad. It changes the way we do the metrics problem. Right? What we're trying to do is anticipate how people will adapt. When they adapt, they will be maladaptive and in the sense of it will create risks from a certain perspective. Right? And there will be benefits. Right? That's one of the fundamental things about adaptive behavior. Locally adaptive behavior does something for those who adapted the behavior. From a larger perspective, we can later come back and go, boy, was that strange behavior, right? And call it error. Right? But we have to recognize, and that's been 20 years of the new look at error, which is error is fundamentally adaptive behavior, locally adaptive behavior that globally is maladaptive when you take a larger perspective and a set of information. So the challenges I want to leave you with are, can we project and anticipate the multiple unintended consequences of proposed changes? What methods do we have? Are we using those methods? Are we getting too local? Are we being locally adaptive and globally maladaptive like in complexity creep? Can we forecast trajectories of adaptive responses? And can we discriminate what's promising so that we can actually participate in steering change in towards expansive adaptations. Back to Colonel Graham's comment, right? Our users are in revolt. They are not waiting for us to figure it out. They are not waiting for us to create new capabilities, new visualizations. They are going to do it. They are going to adapt because they're under pressure to accomplish goals. They experience real risks of bad consequences. Whether we're talking about intensive care units, emergency departments, military systems, crisis management systems, people are adapting. And in that adaptive process, how do we find those open periods that we can help them, right, rather than being reactive? Or rather than just keep throwing new little innovations, hoping one or another will penetrate the walls of adaptation, the adaptive traps they're stuck in. It's a whole new stance and paradigm. But the good news is we actually have most of the work already available. Right? In the end, we already know a lot about how to release human adaptive power. It is through our design innovation process. But we have to harness and link that and model and change our techniques a little bit in order to connect it to our customers and the end users in the world a little differently. Thank you. Comments? Arguments? Yeah.
I've been using a lot of theory from crisis management and trying to adapt it to the non-crisis management situations, like imagine life science, genomics research, which is kind of, it's not actually, it's a big kind of crisis management situation, but there are no human lives involved directly. However, it does involve high cost loss if you think about the big picture. So there is a lot at stake. So do you think this applies to the situations where there is no fire, nobody's dying, but still it's very critical, time-wise or financial-wise?
This is an old debate in some ways, right? Which is, there's the sort of everyday experience, it's the business world, it's whatever, versus there are these high-risk, critical, specialized situations. And one of the changes that the technological world has produced for us is link those two together, right? The stuff that I used to do with mission control or with a nuclear control room are now happening in the business world. They're talking about resilience, not because there's life's at risk, but because the financial stability of the organization is at risk. If you hang around people who make lots of money, these high levels, they don't act like it doesn't matter, right? When they lose out on their bonus, they get really mad, right? When the company goes under and they're out of work, they're not happy campers. So there's always, when you say it's a human system, there's always stuff at stake. And the other way to look at it is be a parent. All right, because when you're a parent, you look at the preteen, for example, or whatever, and they are just obsessed with the crisis in junior high, in middle school. And as an adult, you're like, oh, come on, this doesn't matter a bit about what clothes you wear or what style or which camp you're in, or whatever. But to them, everything in the world depends on that. So again, it's a classic example of balancing perspectives at multiple scales. So that's the paradigm, and that's some of the other work we're doing is, again, combining knowledge from multiple disciplines, putting it together. We're trying to look at what's called polycentric control models. And what are polycentric control models? It actually comes from Tragedy of the Commons. It comes from social scientists like Eleanor Ostrom at IU. And what it is a new way to think of supervisory control or managing adaptive systems. And what you're doing is saying, I've got partial autonomy at different levels. So I've got multiple centers of control, each with partial autonomy, and how do I balance that out? And so they have to be in sort of a creative tension across those levels. And that seems to be one of the key drivers to creating systems that are effectively resilient in the face of change and avoiding a kind of classic pattern of maladaptation, which is called the Tragedy of the Commons. I don't know how many people know the Tragedy of the Commons. Enron, or another thing would be to look at Al Ross' work Another great example of this, he's the husband of one of the top cognitive engineers, cognitive human factors people. Always like to say it that way. You know, he's a famous microeconomist, but he's the husband of a great human factors person. And he has a great paper on how markets unravel, sort of a synthesis on experimental microeconomics. And again, markets unraveling, you start to see these multi-level operations going on. And so he's been doing this on transplant exchange programs, for example, or cross-bid systems, like how do you place residents in or medical students in residency programs. So cross-bid systems are a couple of the examples. Transplant exchange systems. The kidney exchange system right now is working better, finding better matches because of stuff he designed. So these are great examples that we can take these adaptive approaches and that we can do things that improve design. Now, one of the things is when I work with the designers at OSU is it's an interesting challenge because an industrial designer, it's not the normal thing you design anymore, right? But for HCI, it's not the normal thing you design anymore. We're thinking of there's an object, our system word still has kind of an object quality to it. Here's the visualization, right? You have a name for it, all right? And we can get that name in the system, into the larger system, because they make use of a fisheye lens, or they make use of this other technique, or visualization, or a GUI feature that we created. It's saying our design object is quite different when we take the adaptive system stance. Now, adaptive system stance has been around for a while. It's not new. What's new, I think, is that a whole bunch of people are saying, it's matured, now is the time to move. Right? There's enough resources to draw on, and don't let the people who do adaptive system models do it by themselves, because they'll screw it up when it comes to things like emergency rooms and intensive care units and genomics and all the other areas of hyperactivity. Everybody's experiencing brittleness in a highly hyper-interconnected, hyper-pressure world. And they want to be able to respond more agilely. They want to have more foresight. These are the things that we're trying to do. Now, that's why I said they're cross-link levels, right? Because if you're going to enhance adaptive power, what are you going to do? You're going to come up with better CSCW systems. What are you going to do? You're going to come up with better expertise systems like visualization aids and things that give you better feedback, better ability to sort through massive amounts of data, right? But the reason this matters is because of how it helps synchronize, and how synchronization matters is because how it releases adaptive power. We've got to get those three levels interconnected. Yeah.
So sometimes it seems like you can be both hobbling and supporting people's abilities here. So
Yes.
the EICU is a good example.
Yeah.
Where I am no longer in the space, so I'm not hands-on. There's some things that I clearly can't get through a video camera.
Yeah.
But at the same time, you said there are benefits, like taking the high-level view. So is this just become a larger balancing problem now, or how?
Well, the multiple effects problem, that's why I used the crisis management example, because that's a really intense specific example. And this was the first study that just gave empirical support to the observation, the anecdotal observation. And it doesn't have any design implications yet. So, we got to have better balance across sorting the different information sources. But the mixed effects problem, right, that's what you're pointing out. Technology change has mixed effects. And the adaptive stance says, look for and anticipate how those mixed effects are going to play out. And that if we're an effective field, we ought to know a bunch about how those mixed effects are likely to play out. So when we come back and somebody says, oh, this is going to be great, it's going to be a remote monitoring facility. We ought to be able to say, even though we've never walked into an ICU, oh, there's a variety of things that a remote monitoring facility might do that would be effective. And there's a variety of traps that might happen in a remote, because it's remote from the real world. So we would say, what's the value of being on the scene? Is there something special about being on the scene? And so all of a sudden you start going, what is it about being on the scene that's different than only looking at things remotely? Well, one of the things that comes out, for example, is this was shown pretty nicely in the movie Black Hawk Down, or the novel, actually. We don't know if it's really true or not. But so I'll say the novel. It was really great, which is the remote monitoring, right? The commander was monitoring the battle, all right, from feeds on the helicopters over it. And what's striking is he had no feel for how things were going downhill. All right, so your remote monitoring, I know in advance that remote monitoring are more susceptible to late recognition and intervention when things are sliding downhill. They don't see the slide downhill early. We call it going sour. It's a going sour signature leading to an accident. So they're late at recognizing the going sour signature. Right? So there's something special about being on the scene. Now, it's not enough to just be on the scene because we've got lots of going sour cases where there was a resident on the scene who wasn't expert enough to recognize that things were going downhill until there was a collapse in the physiology. So a good place to study this is intensive care units, operating rooms, anesthesiology kinds of places. But there's others. We've done it with aircraft automation. Same thing happens with aircraft automation. So we know this is a case. We also know in highly automated worlds, it's hard to recognize going sour signatures. Why? Because the automation keeps responding to the early trouble, hiding the trouble from the human supervisor until things have gone to hell. And then then the automation goes, here, dude, take care of it. And the guy goes, oh no, what do I do now? Right? And so there's a really cheesy Japanese reenactment of a real aviation accident where a near miss where this happened, and an airplane plunged 20,000 feet before the pilots regained control. So these things really do happen. So we know this pattern, and so remote monitoring has this potential mixed effect. Right? And notice the other reason I used the crisis management UAV example was notice that when we pay the penalties for mixed effects can be different versus when we get the advantages. So the UAV fee gives us advantages right off the bat that everybody sees. They want to take advantage of that new opportunity. They don't want to give it up. The penalties are later in cognitive and collaborative performance in an actual disaster, where they get trapped in the wrong assessment. They have an incomplete analysis of all the data. So one of our advantages would be to help people, right, see that mix. And then one of our things should be is how do we compensate for that mix so we get the advantages that the opportunity represents, because they're going to adapt to take advantage of the capabilities anyway if they're under pressure to do more. Yeah.
I was just curious, is any work being done to investigate, so the system that you described, the EICU and the ICU and the hospital admin, about networking those together into a broader network of knowledge, so to get that holistic schedule, especially in like epidemiology, connecting to things like the CDC, so you can identify trends and
that would be a great thing to get with a public health school who's connected with some public health departments in the area and work on. And we've been trying to do that in Ohio, and we can get more funding or whatever. That's a great opportunity. What's the short answer? In healthcare, what do they think? They think that you can do this bottom up. Collect all the data. Once you have a complete digital system for healthcare, all the data somewhere in the digital system. So then what do you do? Because there's too much data and you can't find anything meaningful, then you must have data mining algorithms. And the data mining algorithms will tell you, aha, here's the outbreak. And you're done then. It'll tell you this. And now you know there was this pattern or trend. And now you know what's going on. Will data mining do some things from massive healthcare databases? Sure. One argument is, the Google argument is that because we can have ultra-massive databases on basic human activities, all we need are bottom-up data mining. We have massive amounts, and we can find these little emergent trends that matter. I don't think, yes, you will have some successes. Will it work overall? I don't think so. It's not really a holistic approach. A holistic approach would combine a bottom-up approach with top-down and a middle-out approach.
So there's no real work being done at that level.
This is what we're crying and crying. I've been crying for 12 years now. 2008, we started patient safety movement in 1996. I've been crying out for 12 years saying, guys, it's all about overcoming the fragmentation. You can't overcome the fragmentation if you just try to say one big massive database will allow us to integrate everything. You have to have other kinds of mechanisms. Top-down may be too hard to initiate given the current structure. So the issue is, how do you do middle out? How do you do decentralized? How do you get emergent properties? What are the key levers that will give you some emergent properties to create continuity? But that's the big target in healthcare. How do you get emergent continuity, all right, over virtual or distance interactions? And you're right, can we get combinations of perspectives? We've done it in the national airspace. We've decentralized authority, and we've created better coordination mechanisms between airline dispatch and strategic air traffic control, so we know when to back off and how to back off when risk is introduced in the system, and how to handle disrupting events in meaningful ways. We've done it on a fairly large-scale system, but national airspace system is tiny compared to the national healthcare system.
There was a system developed by the military for logistics that's been applied to Southwest, I believe it was, for managing their maintenance crews, luggage, ramp, all of that.
Well, we constantly run into people trying to transfer business world solutions, which are related to efficiency and lean, in hyper-controlled settings, to really messy, high potential for surprise settings. Healthcare is a high potential for surprise world, and things that depend on controlling the environment. So the classic applies to automation, right? If you increase the level of automation, level of autonomy of the automation in the system, what's going to happen? I can tell you exactly what's going to happen, right? There will be human roles developed whose job is to align the context gap. In other words, their job is to make sure the world matches the assumptions behind the automation. As long as the world that the automation runs in, it matches its assumptions, it will do things that are really, make everything look real smooth, hyper efficient. The problem is, if the context gap approves, the automation will keep doing what's right for the world it thinks it's in. That's that UAV crash I skipped over. That's the example I use for this. 1999, a UAV has a problem. It takes 6 months in 1999 to plan one UAV mission. Global Hawk. Obviously, they're a little faster now. Many people were involved in it. Onboard failure, software contingency plan, return to base. Lands, stops, goes to look up the next thing to do. There's a bug in the software. And it looks up, nobody had evaluated the interactions across software modules. Instead of looking up the taxi speed, the speed it looks up is the last descent speed. So it tries to taxi and make a 90-degree left turn, accelerating to 150 knots. Needless to say, the physics doesn't work, and it goes careening off and crashing in the desert. What's there? You have the automation does the right thing in the wrong world. Ariane 501, software blows up the rocket launch. Software modules interact. A test piece of software they didn't realize would actually be feeding live data, or feeding non-live data, to one of the monitoring programs to say, is it on course or not? So the monitoring program thinks the rocket's off course, it's not off course, and blows it up. Literal-minded machines, right? And that was what Norbert Wiener was reminding us of and warning us about, is that danger. So people will be there to align and close the context gap. So again, what do we have? A trajectory. There's a technology change. There's certain things we know that are likely to happen or could happen. What do we monitor? Are those things happening? Are the support features for that in place? Or are we going to end up, again, in one of these mixed effect situations? The classic mixed effect situation is where we end up with some successes and problems on one scale, some successes and problems on the other scale. We end up in a debate, human error over automation. I went through this with the aviation industry, going through this with some of in the healthcare industry. And you just point back and forth. There's a screw up. Well, it doesn't matter. Just put more technology in. No, the screw up means that you got too much technology. Stop the technology, right? Just have people do it. And of course, neither of those are stable points out there.
We should probably stop there just to save his voice.
I'm actually fine. I don't know why I've lost it here.
Thank him again.
All right, thanks.